Hi guys. Today we're going to be finding the equivalent resistance of a purely resistive network like this. So as we can see, there's many different resistors in this network, and we want to find the equivalent resistance between the terminals A and B. As we know, series network of resistors, to get the equivalent resistance of a series network is just R1 plus R2 plus R3 plus R4 and so on and so forth. It's just equal to the sum. Parallel resistors, for example, if we have R1 in parallel with R2, it's just the inverses, the sum of the inverses. When you take the sum of the inverse, you inverse that once again. So when we do this latter approach of finding the equivalent resistance between R and A, B, I'll redraw the circuit at each step so we know what's going on. So the first step is we start at the very end. At the very end, we know that the current goes through 2 ohms, 2 ohms, and 2 ohms. So we know that since the current goes through these, the same current goes through these, we know that these are in series. So we could say, okay, well, 2 plus 2 plus 2 is equal to 6 ohms. If we redraw the circuit, we could see that this becomes 6 ohms, this becomes 6 ohms, 3, 12, 8, 4, 4. And we can see that these were in series, so the total is 6 ohms. Now, as we could see here, these two resistors are in parallel. So since these two resistors are in parallel, what we do is say 6 is in parallel with 6, which is equal 1 over 6 plus 1 over 6. Inverse that, and that becomes 3 ohms. So if we redraw the circuit again, this becomes 3 ohms, 3, right? So this, since 6 is in parallel with 6, we would get 3. As we could see, the current goes from 3 ohms into this 3 ohms too. So since these two have the same current going through them, well, we could say, well, 3 is in series with 3, so 3 plus 3 equals 6. Again, we could redraw the circuit again. If we redraw the circuit again, we get something that looks like this, where this is 6 ohms, 12 ohms, 8 ohms, 4 ohms, 4 ohms, 4 ohms. Now this circuit looks a little complex because we have this branch that looks like it's going in a diagonal, but in theory, and what it actually is 12 is in parallel with 6. So we could actually redraw the circuit. Where we have 4 ohms here, 8 ohms, 4 ohms. We have 12, and we have 6 ohms. So these are equivalent circuits. The diagonal branch, or the diagonal terminal that's going across here is just, you could rewrite it like this. It's just the same thing. So as we can see here, 12 ohms is in parallel with 6 ohms. So we say 6 is in parallel with 12, just 1 over 6 plus 1 over 12. You take the inverse of that. To take the inverse of that, this comes out to being 4 ohms. So again, we could redraw the circuit again. So since we draw this circuit, we could say, okay, well, the current going into here is the same current that goes through here and goes through here too. So we could say, okay, well, 4 ohms will be in series with this 4 ohm resistor too. So we say 4 plus 4 equals 8. Can we draw the circuit again? This is the 8 ohm resistor here. And we have 4 ohms and 4 ohms here. So again, we could say, okay, well, 8 is in parallel with 8. So 8 in parallel with 8 is equal to 1 over 8 plus 1 over 8 inverse is equal to 4 ohms. Key point to point out to do a fast method of this, whenever you see 2 resistors with equal values in parallel, the parallel equivalent would be half of that resistor. So for example, 8 in parallel with 8 is 4, 6 in parallel with 6 will be 3, 2, what is it? Like, let's say 9 in parallel with 9 would just be 4.5. So that's what, just the fast method of doing that. So the 8 in parallel with 8 would be 4, so we can redraw the circuit again. So we have 4, 4, 4. Now, the current that goes through here is the same current that goes through all these resistors. So since the current is the same through all these resistors, we say that these 4 ohm resistors are in series. So we say 4 plus 4 plus 4 is equal to 12 ohms. So therefore, if we do the equivalent resistance, so these terminals A and B, it says RAB, the resistor here would be 12 ohms. So as we can see, we started with a very complex circuit like this. And we started at the very end and we worked our way all the way to the left-hand side to find the equivalent resistance of RAB, which turned out to be 12 ohms. So this is just a simple example to find the equivalent resistance of a purely resistive network. Awesome. Thank you.